Okay, so probably should have had this open
Chapter
before I
5
started
practice.
recording. Yeah, thank you.
Yep.
This
So
is
we
how
are
I
on
do the scan.
F4. F4. Okay. So this is the problem that we're doing. For sure my audio is recording, right?
Yeah. Yeah, you're for sure.
All right.
Fucking hope so. Where is it?
So let's go ahead. You can just set it up, and I'll tell you the numbers.
Okay.
Mhm.
Oops, is this the wrong one?
No, that's right. F4.
Okay, yeah.
Right. So all right. So I like to set it up XYZ just because there's no X1. So X1, X2, X3 will make into XYZ. So Y will be a new matrix of 2, 0, 0, 2. Okay, and our X3 or Z, that'll be 1, 1, negative 1, 1.
Okay.
All right, so that's X1, X2, X3, right? So we need to normalize. Let's start with X. We actually
this?
can kind of do that on paper.
No, you can't. Okay.
No, I mean, maybe. X, the square root of 4 squared plus,
Yeah,
so
cool, you can.
16 plus 4 plus 4 plus 1.
16 plus... Oh god.
4.
Hold on, because I was starting with the square root. So 16 plus 4. Oh my god. I'm just gonna do this. 4 squared plus...
2 squared.
Oops.
Plus 1 squared.
Okay.
Okay,
So
fraction.
that equals... And so that equals
And
U1.
then,
Right?
yeah, which in the graphing calculator, we'll just call it U.
Okay.
You can create a new matrix.
Oh, I can't do it like that. Okay.
But yeah,
U.
by the way, people just, I don't know if everyone was at the review, but Foreigner did say that we can use multiple windows of Desmos open
Cool.
Yeah.
because of the amount of
Okay,
matrices
cool.
we have to use.
All
And
right,
so basically, we didn't mention it before, but this is the Gram-Schmidt method, right?
Mhm.
So of solving this, to get the orthonormal basis for this subspace in R4, right? And so here, what we'll be doing is taking, actually, we want to do x2 or y projected onto, so y minus the projection of y onto u1, right? So y minus u times u transposed.
Oh, it's U times... Okay. Times Y?
Times y. And so what this is giving us is the difference between the projection and u, but we want to normalize it still. So divide that. So I usually go ahead and make another line.
Okay.
So that you could just do square root of let's see, so 2/5 squared, yeah, plus
Oops.
4/25.
Oops.
Wait, no,
Oh,
actually,
sorry, that's 16/25. Oops.
16. You're right. Plus 16/25.
Plus 64/25.
Mm-hmm.
Okay.
And so we want to get rid of both of those sixes. But hold on, it's not 256, it's 25.
Oh, oops, I meant to... Yeah.
And then it's not 26, it's 25.
Oh, typo city.
Okay, so basically we're dividing this difference by 2. That's our U2, right? That's the second unit vector of our basis.
What should I label this
So
one?
this would be V. V.
Okay.
U, V, W. New matrix. 1/5, -2/5, -2/5, and 4/5.
Cool.
Okay, fantastic. Now we have our U2. Now we need to find U3. So we'll start off with our Z, x, y, z, with our last vector, minus projection. So we need both of the projections. We need U.
Oops. I'm doing that right?
Yeah, you could do that. Yeah, so times Z minus our U times U transposed
Oops.
times Z.
Also
So
times Z.
we are removing the projection of Z onto U1 and the projection of Z onto U2. Now we need to normalize this. So
Divided by 2.
0 squared plus 1 squared plus, yeah, so it's divided by the square root of 2. So really what you can do is you can remove the square root of 2 on the denominator, each of those elements divided by square root of 2. So 0, 1 divided by square root of 2, -1 divided by square root of 2, 0. And that's our W, I'm calling it.
Okay.
UVW. And those are our unit vectors for the basis of the subspace of R4. And what I like about using Desmos is it's just like, as long as you understand it, you can just like, okay, just work it through.
So, and we can
if you
double check
notice,
this now too, right? So we can be like, okay. Times. Oh, I thought that was supposed to get 0, but okay.
how can we double check it?
Orthonormal should mean that any one of them can be dotted.
That means U and V can be dotted.
Oh, right, okay. Oops. Okay, so
yeah. Or V
and
W.
Right, okay. So, yeah. So we at least know they're orthogonal with that check, and then we know they're normal because they've all been normalized.
Yes.
So that's your answer. U, V, and
Can I
W.
ask a question?
Yes,
Recording
please.
or
Um, yeah, so I got lost. So I created created matrices for the 3 vectors,
no? Mm-hmm.
and then I just stored the normalized vector into another matrix, and then yes, and then okay.
And so that matrix becomes your U1, right?
Can you scroll
Or
up?
the first unit
Yeah,
vector.
so that's my normalized vector, and then we did the
Same here.
what did we do? We took y minus okay, and we did divide it by 2, and so how does that
Because
how
that
did
was the
that work out?
normalization. Here, I'll show you. So that was the
Yeah,
same.
minus.
That was the same thing as doing.
Get rid of the 2. Yeah, so you can't see it if
Oh,
you're not.
right, because the square root all of that equals to 2. Okay, gotcha. Okay. That's where I was getting confused.
It's actually
Like,
not.
why are we just dividing by 2? But
What question are you guys working on right now? I just joined this.
the magnitude part.
F something. This is a guide being recorded too, by the way. Just a heads up. I'm gonna post a video for everybody.
Okay, so the y minus the. Can you stay up there on the.
Right here?
The y minus the u transpose y. That's the p1, the projection. But then we have to normalize that, but somehow just taking that over the square root is the same as normalizing it.
Yeah, I mean,
Yeah, okay.
that's how you normalize or unitize.
Okay.
And then we did, you know, same thing here.
We just store that in the V matrix.
Yeah, exactly. And that information was, yep. So yeah, that's how to do it in Desmos.
Can I have you change something real quick?
Yeah.
Because I'm wondering why. Okay, so no, at the y minus you transpose y. So you're doing a little bit of a shortcut, and it's hiding what we're actually doing.
Okay.
Can you erase that entire denominator? So 2/5, 4/5. Yeah, that's what I thought. You were actually not putting
Oh,
in
I
the
did it
correct
wrong.
number.
I did it wrong.
So,
So it was
enter.
unitized.
Press enter. Just go to the next line. Let's take the square root of what we have there.
Oh, it's the exact
So
same
it's,
issue
it's
as
over
before.
this. Yeah, it's over this.
2/5
Yeah.
squared plus 4/5 squared plus 4/5 squared plus 8/5 squared. Or you can make all denominators the same, have them all be over 25.
Oops.
So 4 plus 16 plus 16 plus 64 over 25.
Oops. Yeah,
Yeah,
so
no
that
worries.
equals 2.
There we go. Now we have our 2. And then we're just taking all those, that vector on the right, divided by 2, that's our v. So that's
And then we did the
kind
same
of the
thing here.
step that we were.
We divided this by square root of 2, and we got this answer.
Yeah.
Because 1 over square root of 2 equals that decimal approximation. Okay. So that's how you do it. Way better than any way anybody else has ever taught me. Thank you again, Dave the Wave.